Analytical Chemistry 2.0 by David Harvey. Chapter 1. Introduction to Analytical Chemistry. Chemistry is the study of matter, including its composition and structure, its physical properties, and its reactivity. There are many ways to study chemistry, but we traditionally divide it into 5 fields: organic chemistry, inorganic chemistry, biochemistry, physical chemistry, and analytical chemistry. Although this division is historical and, perhaps, arbitrary, as witnessed by current interest in interdisciplinary areas such as bioanalytical chemistry and organometallic chemistry, these 5 fields remain the simplest divisions spanning the discipline of chemistry. Training in each of these fields provides a unique perspective to the study of chemistry. Undergraduate chemistry courses and textbooks are more than a collection of facts. They are a kind of apprenticeship. In keeping with this spirit, this chapter introduces the field of analytical chemistry and highlights the unique perspectives that analytical chemists bring to the study of chemistry. Section 1a. What is analytical chemistry? Analytical chemistry is what analytical chemists do. Let us begin with a deceptively simple question. What is analytical chemistry? Like all fields of chemistry, analytical chemistry is too broad and too active a discipline for us to define completely. In this chapter, therefore, we will try to say a little about what analytical chemistry is, as well as a little about what analytical chemistry is not. Analytical chemistry is often described as the area of chemistry responsible for characterizing the composition of matter, both qualitatively, is there any lead in the sample, and quantitatively, how much lead is in the sample. As we shall see, this description is misleading. Most chemists routinely make qualitative and quantitative measurements. For this reason, some scientists suggest that analytical chemistry is not a separate branch of chemistry, but simply the application of chemical knowledge. In fact, you probably have performed quantitative and qualitative analyses on other chemistry courses. Defining analytical chemistry as the application of chemical knowledge ignores the unique perspective that analytical chemists bring to the study of chemistry. The craft of analytical chemistry is not in performing a routine analysis on a routine sample, which more appropriately is called chemical analysis, but in improving established analytical methods, in extending existing analytical methods to new types of samples, and in developing new analytical methods for measuring chemical phenomena. Here is one example of this distinction between analytical chemistry and chemical analysis. Mining engineers evaluate the value of an ore by comparing the cost of removing the ore with the value of its contents. To estimate its value, they analyze a sample of the ore. The challenge of developing and validating an appropriate quantitative analytical method is the analytical chemist's responsibility. After its development, the routine, daily application of the analytical method is the job of the chemical analyst. Another distinction between analytical chemistry and chemical analysis is that analytical chemists work to improve and extend established analytical methods. For example, several factors complicate the quantitative analysis of nickel in ores, including nickel's unequal distribution within the ore's complex matrix of silicates and oxides, and the presence of other metals that may interfere with the analysis. Figure 1.1 shows a schematic outline of one standard analytical method in use during the late 19th century. The need for many reactions, digestions, and filtrations makes this analytical method both time-consuming and difficult to perform accurately. The development, in 1905, of dimethylglyoxime, DMG, a reagent that selectively precipitates nickel 2+ and palladium 2+, led to an improved analytical method for the quantitative analysis of nickel. The resulting analysis, as shown in Figure 1.2, requires fewer manipulations and less time after completing the sample's dissolution. By the 1970s, flame atomic absorption spectrometry replaced gravimetry as the standard method for analyzing nickel in ores, resulting in an even more rapid analysis. Today, the standard analytical method utilizes an inductively coupled plasma optical emission spectrometer. A more appropriate description of analytical chemistry is the science of inventing and applying the concepts, principles, and strategies for measuring the characteristics of chemical systems. Analytical chemists typically operate at the extreme edges of analysis, extending and improving the ability of all chemists to make meaningful measurements on smaller samples, on more complex samples, on shorter time scales, and on species present at lower concentrations. Throughout its history, analytical chemistry has provided many of the tools and methods necessary for research in the other traditional areas of chemistry, as well as fostering multidisciplinary research in, to name a few, medicinal chemistry, clinical chemistry, toxicology, forensic chemistry, materials science, geochemistry, and environmental chemistry. You will come across numerous examples of analytical methods in this textbook, most of which are routine examples of chemical analysis. It is important to remember, however, that non-routine problems prompted analytical chemists to develop these methods. The next time you are in the library, look through a recent issue of an analytically oriented journal, such as Analytical Chemistry. Focus on the titles and abstracts of the research articles. Although you may not recognize all the terms and analytical methods, you will begin to answer for yourself the question, what is analytical chemistry?